Hey guys, welcome back to geometry. Today we're going to take a look at some special angle pairs. Now, last time we were talking about just angles in general, the way we measure them, making comparisons between them. But today we're going to get into some relationships that exist between different angles. So these terms are things that we're going to use throughout the year, so we need to make sure that these are some of the terms that we know. Okay, we don't have to look these up, we just know these ones off the top of our head. So first off, we've got adjacent angles. Now, in our diagram over here on the right, we have an example of adjacent angles. Okay, we have angle EHF and FHG are adjacent angles. Now, if we think about what it means for angles to be for anything to be adjacent, adjacent means right next to. In for angles, that's no different. Okay, they are right next to each other. Now, we do want to get just a little bit more specific though, and give it a mathematical sounding definition. They're angles in the same plane, so we could draw them on the same piece of paper. They have a common vertex, so notice how each of these have their vertex at H. And they have a common side, so both of these angles share this side HF. But they have no common interior points. So take a look at these two angles. Take a close look. We have angle EHF, that's this guy, EHF. And we have angle FHG. Okay, those two angles share this vertex H. They share this common side HF, but that's it. They don't share any points in the interior. Okay, and that's a key important point when we're talking about adjacent angles. They cannot share any points. There can't be any overlap. Okay, next up, we have vertical angles. Now, vertical, when we think of that, we think straight up and down. So this name doesn't help us so much with how these angles are paired. But if we look at this diagram, and we see that angle 1 and angle 3 are vertical angles, and angle 4 and angle 2 are vertical angles. So if we try to describe what these pairs of angles look like, what we'd probably end up saying is that they're two non-adjacent angles. So they're not right next to each other. They don't share a common side, but they are formed by two intersecting lines. Okay, so they're formed by, they're formed by this line and this line. Those two lines form all four of those angles. Okay, the only thing that those vertical angles share is a vertex, and that's actually where the name comes from. Vertical comes from vertex. They share a vertex, nothing else, but they're formed by the same two lines. Now, what always happens with vertical angles are always congruent, and that's a nice little trick to have up our sleeves. Okay, the next pair of angles that we want to discuss is something called a linear pair. Okay, now what's really important about this linear pair is this word pair. Okay, it has to be two. You can't have a linear pair with three or more angles. It has to be exactly two. Now this description over here, this diagram, shows us that angles 5 and 6 form a linear pair. So if we try to describe what happens with the linear pair, well, think about this. This word linear. Okay, linear means having to do with a line. So if I put this pair of angles together, it forms a line. That's basically what a linear pair is. Okay, it's adjacent angles. They're right next to each other. They share a common vertex and a common side, but no points in the interior. And their non-common sides form opposite rays. Okay, so angles 5 and 6, they share this common side right here. Okay, but their non-common sides are opposite rays. They form a straight line. Okay, that's what makes a linear pair. Okay, next up, we have complementary angles and supplementary angles. Now, these have very similar names, but they mean kind of different, well, very different things, actually. These two angles here are complementary angles. These two angles are supplementary angles. Now, notice those angles don't have to be together. They don't have to be adjacent. They don't have to be vertical. They just have to be in the same picture. Okay? Now, complementary angles, the only thing that really happens that they've given us is these two measures. Well, 60 and 30 together gives me 90 degrees. Complementary angles sum to 90 degrees. Supplementary angles sum to 180 degrees. the really easy way, the best way I think to keep this straight is complementary starts with a C, supplementary starts with an S. In the alphabet, C comes before S. In numbers, 90 comes before 180. Okay? Now, the last thing that we have isn't exactly a pair of angles, but it is an important thing that fits with the rest of these. Okay, perpendicular lines. Perpendicular lines are lines that intersect to form a right angle. So I have these two lines here, K and M. They intersect at a right angle, so we would say K is perpendicular to M. Okay, and this symbol here that looks like an upside down T, that means is perpendicular to. Okay, so here we go. Here are terms that we want to know, the things that we want to have nailed down before we go any further. Okay, we have adjacent angles, angles that share a common vertex, a common side, but no common points in the interior. Vertical angles are two non-adjacent angles formed by two intersecting lines. Linear pair are adjacent angles whose non-common sides are opposite rays. Complementary angles are two angles whose measures sum to 90 degrees. Supplementary angles are two angles whose measures sum to 180 degrees. And perpendicular lines are lines that intersect to form a right angle. Okay. Next up, let's put some of this into work. Okay, the first couple examples we just want to describe. We'll work with those definitions a little bit. So we want to name an angle pair that satisfies each condition. So two obtuse vertical angles. Now remember, vertical angles are formed by two intersecting lines. So if I look at this diagram, the only pair of angles, or excuse me, lines I have that would satisfy that are these two, lines AG and lines EN. So if I want vertical angles, we'll take a look back at our description. Okay, vertical angles are formed by intersecting lines. Okay, and they are on opposite sides of that intersection. They share a vertex and nothing else. So if I take a look at this diagram, from these two lines, I could say that these two angles are vertical, or I could say that these two angles are vertical. But the catch is they want obtuse vertical angles. And obtuse means greater than 90 degrees. So the only angles that I have that would be greater than 90 degrees is angle ASN. That's the only one that I can see right away. But keep in mind, just because there's this line right here doesn't mean that this angle doesn't exist. So that's my other half of that pair of vertical angles. Angle ASN and angle ESG. Those would be my obtuse vertical angles. Now next up, we want two adjacent acute angles. Okay, well, adjacent angles share a common vertex and a common side and no points in the interior. So for that, all I need to do is pick a side. Okay, a side the two angles share. So how about this? Ray SL gives us two adjacent angles. Okay, I have this guy and I have this guy. Those two angles would be adjacent angles. And they both are acute. This one's 50 degrees, this one's 65 degrees. So my two acute adjacent angles would be angle ESL and angle LSG. Okay, let's take a look at example 2. Example 2 says, find the measure of two complementary angles if the difference in their measures is 12. So first off, we have the fact that they are complementary angles. And then we have the difference in their measures is 12. Now, complementary means that these two angles have to add up to 180 degrees. So we have, let's say, measure of angle 1 and measure of angle 2. Now, I'm going to call angle 1 X, and I'm going to call angle 2 Y. And this is just going to give me a little bit less writing that I'll have to do. Now, I have that they are complementary. Complementary means that their measures have to sum to 180 degrees. So I can say X plus Y, excuse me, not 180 degrees. Complementary means 90 degrees. So X plus Y has to equal 90. Now I also have that the difference in their measures is 12. Now difference means subtraction. So if I do x minus y, I'll get 12. So I have these two equations, and I need to solve them. The trouble is I have two different variables. So what we have to do is fall back on a trick from Algebra 1 and Algebra 2 called solving by substitution. So the first thing I'm going to do is take this second equation, and I'm going to solve it for x. So I'll add y to both sides, and I'll have x equals 12 plus y. Now, the reason that we do that is now we have an expression that's equal to x. And what we can do is put it in place of x in the other equation. So we'll have 12 plus y in place of this x right here, and then bring down this plus y equals 90. Now we have an equation that's all in one variable, and we can solve it. So we combine our like terms, and we have 12 plus 2y equals 90. Subtract 12 from both sides, and 2y equals 78. Divide both sides by 78, and I get, or excuse me, divide both sides by 2, and I get y equals 39. Now that gives me the measure, or excuse me, that gives me the value of y. I can now use this to find the value of x by subbing that into the other equation. So x equals 12 plus 39, and I get that x equals 51. So, the two angles, find the measures of two complementary angles if the difference in their measures is 12. So those measures are 51 degrees and 39 degrees. And there we go. All right. Now, let's take a look at a couple more. Next up, I want to find x and y so that ray BE is perpendicular to ray AD. So let's take a look at those rays first of all. Here's ray BE, and here's ray AD. Okay, if I want those to be perpendicular, remember perpendicular means it forms a 90-degree angle. Well, that means that all of these angles have to be 90 degrees. So this 12y minus 10 has to be a 90-degree angle. So I can use that to find y. So 12y minus 10 has to equal 90. Add 10 to both sides, and I'll get 12y equals 100. Divide both sides by 12. Now we're going to get a decimal. That's okay. Okay, if we do 100 divided by 12, we're going to get 8.3 repeating. Now, guys, just because you get a decimal doesn't mean you did anything wrong. Did anything wrong, especially if it's something like 0.3 repeating, because that is the same as 8 1/3. Okay, and 1/3 is a pretty common fraction. So y is going to be 8.3 repeating. Now we also want to find x. Now the catch is with x, it's two separate angles, and I don't necessarily know what the measure of either of those angles are, but I do know that this big angle has to be 90 degrees. So that means if I take 6x plus 3x, those two angles together have to equal 90. So combine your like terms. 6x and 3x equals 9x equals 90. Divide both sides by 9. And we get x equals 10. So y equals 8.3 repeating, and x equals 10. Now, one really important note about these diagrams, guys, this is a really big deal. We always have to keep in mind that we must go by how the diagram is labeled. We cannot make any assumptions based on how it looks. Cannot make any assumptions based on appearance. Okay? And I would like that to be a different color. Highlight it all and make it blue. Okay? So with diagrams, we cannot go by how they look. We have to go by how they're labeled. Okay? So that works both ways. Not just if it looks perpendicular, we can't assume that, but also if it's labeled one thing, okay, say these two, let's say I tell you that these two angles are congruent. Okay, I'm not telling you that, but let's pretend that I do. Even though they don't look like they're the same measure, if I tell you that they are the same measure, then they have to be. So we have to go by how a diagram looks, have to go by how a diagram is labeled, and we cannot make any assumptions based on how it looks. Okay, so now let's keep on rolling here. We want to determine whether each statement can be assumed from the figure. Okay, so they have LPM and MPO are adjacent angles. So, well, first off, let's highlight this. We have angle LPM and angle MPO. Whoop, that's MPN. MPO. We want to know if those are adjacent angles. Well, go back to what adjacent angles are. Adjacent angles are angles that share a common vertex, a common side, and no points in the interior. These two angles definitely look like they satisfy that. Okay, we can assume that they share this side and they don't overlap. So yeah. They want to know if this can be assumed from the figure. The answer is very simply yes. Okay, next up, they want to know if we can say that OPQ and LPM are complementary angles. Well, let's highlight those and focus on them. So here's OPQ, and here's LPM. Okay, we want to know if we can assume that those are complementary angles. Well, complementary angles means that they have to sum to 90 degrees. This one's a little tricky, okay, but we can work our way through this with a little bit of logic. Okay, this whole angle, the whole thing, has to be 180 degrees. And if we look closely at this diagram, they tell us that this part is 90 degrees. Well, if the whole thing's 180 and this piece is 90, with a little bit of arithmetic, we can see that whatever's left must also be 90 degrees. Okay, so if I take away that square of 90 degrees, these two pieces here have to add up to 90 degrees. Well, the definition of complementary angles is that those angles sum to 90 degrees. Those two angles have to add up to 90 degrees from this diagram. So the answer here is also yes. Okay. Now, these assumptions that we make are not always directly from what's labeled. Sometimes we have to take a little bit further. We have to read it and interpret that graph. Okay. Now, last up. They want us to know, or they want us to say, if we can determine that angle LPO, so LPO and QPO are a linear pair. Okay, now, what does it mean to be a linear pair? Okay, a linear pair is this. Okay, angles, adjacent angles whose non-common sides are opposite rays. So they're adjacent and they form a straight line. Well, these two angles that we've highlighted, do they look like they meet that requirement? Absolutely. We have line LQ, and we have ray PO. Okay, ray PO makes these two angles adjacent, and line LQ means that their non-common sides are opposite rays. So yes, we can make that assumption as well. Okay, sometimes, guys, when these assumptions that we make, they're not as simple as just a quick look at the diagram. Sometimes we have to think a little bit, and what really makes that possible is knowing those definitions. All right, I want to take a look at just a couple more examples. Okay. These ones, the first ones are just identifying the terms. So I want to identify each pair of angles as adjacent, vertical, complementary, supplementary, and or as a linear pair. Now what that means, guys, is some of these could be more than one. We have to pay close attention. So angles 1 and 2. So angle 1 and 2, let's highlight those. Here's angle 1, here's angle 2. Now what I can say about those is, are they adjacent? Well, they share this vertex right here, and they share this common side. So yeah, I can say they're adjacent. Okay, next up, I want to know if they're vertical. Well, they cannot be both adjacent and vertical. What we said in those first definitions is that a vertical angle is non-adjacent. So if it's one of those, it cannot possibly be the other. Next up is complementary. So complementary means adds up to 90 degrees. Well, I can see that this angle here is 90 degrees, but I don't know anything about this angle. So I cannot necessarily say that they're complementary. The same problem comes up with supplementary. If they're supplementary, that means that if they're adjacent and supplementary, they're going to form a linear pair. Angles 1 and 2 don't look like they do that. So we cannot make that assumption from this diagram. Okay, and like we just said, if they don't look like they form a linear pair, they don't. Okay, so we cannot move on this. So all we can say is that angles 1 and 2 are adjacent. Okay, how about angles 1 and 4? Okay, here's angle 1, and here's angle 4. Now, angles 1 and 4 are formed from these two lines, from this guy and this guy. Angles formed from this, let me try this again. Angles formed from the same two lines that share no common points, no common sides, just this vertex, we call those vertical angles. So those are definitely vertical angles. And if they're vertical angles, they cannot be adjacent angles. Complementary means they add up to 90. Supplementary means their measures add up to 180 degrees. I don't really know enough about this diagram to make that assumption. Okay? If I knew that they were each 45 degrees, I could say that they were complementary. If I knew that they were each 90 degrees, I could say that they were supplementary. But I don't know that. So the only thing that I can say about these angles is that they're vertical. And if they're vertical, they cannot be adjacent. Part of the definition of linear pair is that they have to be adjacent. So the only thing I can say about those angles is they're a linear pair. Okay, next up, we have angles 3 and 4. Okay, angles 3 and 4 are definitely adjacent. They share this vertex, they share this common side. So we can say they're adjacent. If they're adjacent, they cannot be vertical. Complementary means they add up to 90 degrees. Now guys, if we take a look at this really closely before I marked it up, there's a tiny little square right here. That square means that those two rays are perpendicular. Perpendicular means they form a 90-degree angle. So these two angles together have to form that 90 degrees, which makes them complementary. So complementary means they add up to 90 degrees. Supplementary means they add up to 180 degrees. So if it's one of these, it can't be the other one. And if it's not supplementary, it can't be a linear pair. So angles 3 and 4 are adjacent and complementary. Okay, then we have angles 1 and 5. Well, angles 1 and 5, they're definitely adjacent. They share this vertex. They share this common side. If they're adjacent, they cannot be vertical. Complementary means they add up to 90 degrees. Well, I don't think they add up to 90 degrees because 90 degrees would be perpendicular. Okay, but they do have opposite rays as their non-common sides. So that means that they are a linear pair. They're adjacent, their non-common sides form opposite rays, they're a linear pair. A linear pair is always supplementary. Okay? All right, last couple I want to look at here. A couple of algebra ones where I need to find the value of x. So I want to look at here where I have these two angles. Now these angles are vertical angles. They're formed by these lines and they share nothing but that vertex. Now vertical angles, we said on the very first page, are always congruent. which means that 5x has to equal x plus 16. So we've got ourselves an equation. Let's go ahead and solve it. Subtract x from both sides, and we have 4x equals 16. Divide both sides by 4, and we have x equals 4. The directions say find the value of x. There we go. Okay, next up, number 6. Okay, I see these two angles here. Now guys, this side and this side are very clearly opposite rays. We can assume that a line is a line if it looks like a line on the diagram. So these are opposite rays, which makes these two angles a linear pair. Linear pairs are always supplementary. So that means that 7x plus 10 plus 3x has to equal 180 degrees. So now we combine our like terms, and we have 10 plus 10x equals 180. Subtract that 10 from both sides, and we'll have 10x equals 170. Divide both sides by 10, and we'll get that x equals 17. Okay, last one. Okay, this one's really similar. Now, if we look closely, we can see this little perpendicular symbol, which means 90 degrees. So these two angles together have to add up to 90 degrees. So 4x plus 3 plus x minus 8 equals 90. Combine your like terms. 5x minus 5 equals 90. Add 5 to both sides, and we'll have 5x equals 95. Divide both sides by 5, and we'll get x equals 19. Okay, and there we go. So guys, what it all comes back to are these first couple of definitions. Adjacent angles are angles in the same plane with a common vertex, common side, but no points in the interior. Okay, so what you have, they share one side, and then they have two other sides. Vertical angles are formed by two intersecting lines, and they have nothing but the vertex in common. A linear pair are two adjacent angles whose non-common sides are opposite rays. So adjacent means they share that common side, but their non-common sides are opposite rays. Complementary are two angles whose measures add up to 90 degrees. Now what's important here is that we don't necessarily know that those angles are adjacent. We just know that their measures have to add up to 90 degrees. Finally, we have supplementary angles. Supplementary angles are angles whose measures add up to 180 degrees. And again, they don't have to be adjacent. They just have to add up to 180 degrees. The last thing that we talked about were perpendicular lines, which aren't exactly angles, but they do give us this right angle, which is 90 degrees. Everything that we could have to do in this section comes back to these definitions. Guys, these are ones I don't ask you to memorize a whole lot. These are some terms we definitely want to know. All right. If you have any questions about this, guys, please make sure you contact me one way or another, get those questions answered.